So today I'm going to show you a method of factoring trinomials that will work on any factorable trinomial. It won't always be the best or fastest or most efficient route, but it will always work. Now, as you can see, I'm working with this sort of 4-area model. And on the left, I'm going to show the steps that we're going to follow, and on the right, I'm going to give you an example. So we're given 4x squared plus 12x plus 9. Okay, following our area model, we know that the 4x squared is going to go here, and the 9 is going to go here. And part of our job is going to be to take this 12x and fill in these two regions and use that information to find these sides. And that'll give us our factored form. Those two sides multiplied together make the same area. Okay, so it used to be when we just had x squared that just knowing the area of that upper left square was good enough because we would have x and we would be good to go. We don't have that luxury any longer. Now we've got 4x squared. Well, it could be 4x times x, or it could be 2x times 2x. So we have some detective work to do, essentially. Our first step in factoring, every single time, forever, anytime you're told to factor, the first step should always be to look for a GCF. Is there any number that I can divide out of all three parts of the trinomial, out of all three terms in the trinomial? In this case, no, there isn't, but it is always worth looking. You should always check for a GCF just in case. Step 2. We're going to multiply the values of a times c. A is that 4 in front of the x squared, c is that 9. So a times c is 4 times 9, which is 36. Now, this seems unusual, like why are we multiplying a times c? But that's because this value here does very much affect the multiplication that it takes to get into these two regions. We have to take both a and c into account when we are splitting up, when we're divvying up our x's. And then we're going to do the same thing that we've been doing. We're going to take 36, and we're going to look for a factor pair that multiplies to make 36 and adds up to 12 so that we can fill in those two regions. Okay, what I'm seeing is 6 and 6. 6 times 6 is 36. 6 plus 6 is 12. So we are going to fill in our two regions with 6x and 6x. Now at this point, you should be able to use the diagram to determine the values of these sides. If you are a person who learns visually or loves using these diagrams, you should be good to go from here, and you can ignore the rest of this video. For those of us who don't necessarily rely on diagrams so much, I'm going to give you a step-by-step way of doing all of that sort of detective work without having to rely on a diagram. So step 3 was find the factor pair that adds up to b. In this case, it was 6 times 6. Okay. Step 4. Now, once we had these two numbers, the two numbers that multiplied to make AC and add to make B, when we just had x squared, when we did not have a 4x squared, when it was just 1x squared, we were done, right? You could just copy down x plus 6 in this particular case, and you'd be done. Now it's a little bit more complicated because we still have that 4 to contend with. So step 4 is going to be split the middle term, and I'll show you what that means in a second. We are going to rewrite this equation, but we're going to take that 12x and we're going to split it up into the two numbers we just found, in this case 6 and 6. So we have 4x squared plus 6x plus 6x plus 9. So again, just a It's the same thing we just did with the diagram, it's just that we're not using a diagram. And like the diagram, we can do some division here to figure out what the two sides are. Step 5 is called factor by grouping. We are going to split our expression in half, and we are going to look at what can be factored out of each half. So if you look just at this first half right here, what can be factored out of those two terms by themselves? Well, I see that they're both even, so they're both divisible by 2, and they've both got an x. So after we factor that 2x out, we're left with, let's see, 4x squared divided by 2x is 2x. 6x divided by 2x is 3. Okay. Don't forget that plus, because we are still adding everything together. Now look at the second half. Now look at the second half of the equation. What can be factored out of that? Well, it looks like both of these numbers are divisible by 3. 6x divided by 3 is 2x. 9 divided by 3 is 3. Now you'll notice, and it's very important that this is true, these two terms, or these two factors, are identical. And it's very important that they're identical. It's how you know that you're on the right track, because what we're going to do next is going to require that those two be equal. So if there is any difference between those two parentheticals, you have done something wrong or there is something wrong. Now, what this basically says is we've got our sides, right? We now know that one side is 2x plus 3 and the other side is 2x plus 3. What we're doing from a math standpoint is we're taking the 2x plus 3 factor, and just like we did with x and just like we did with 3, we are factoring it out. So we're factoring that 2x plus 3 out to the front, and then whatever's left makes up our other factor. In this case, another 2x plus 3. So our final answer is 2x plus 3 squared. Now, it's a lot of steps, but each step isn't so bad. And again, this is a method that will work no matter what. So this should absolutely be in your notes when you come in to do the exam. Let's do a couple more examples, except I'm going to do them without the aid of the diagram. So if you have any trouble following, go back, watch the first bit again. Okay, we have 4x squared plus 18x minus 10. We want to factor it completely. Now, some of you are already rushing to multiply a times c and look for factor pairs, but don't forget the first step that you should always take when factoring. Is there anything that is a greatest common factor between those three terms? And the answer in this case is yes. We can factor out a 2. And when we do that, well, 4x squared divided by 2 is 2x squared. 18x divided by 2 is 9x. And negative 10 divided by 2 is negative 5. We're making the numbers smaller to make our lives easier. You could just jump straight to multiplying 4 times negative 10 and get negative 40 and go from there. You would still get to the correct answer, but this makes it so much easier. Okay, so we're going to ignore that 2 for a moment and just work with the trinomial. A times c is 2 times negative 5, which is negative 10. We need two numbers that multiply to make negative 10 and add to make positive 9. I'm seeing 10 and negative 1. 10 times negative 1 is negative 10. 10 plus negative 1 is positive 9. Now remember, we can't just go straight to parentheses. Since we have that 2x squared, we need to split the middle term. So the 2 is going to stick around. 2x squared plus 10x minus 1x minus 5. Once again, splitting into two binomials. This side here. Again, I'm going to kind of ignore the 2 for a moment. It's going to make its appearance at the end. Don't forget about it. So I get 2x times, what's that? 2x squared divided by 2x is just x. 10x divided by 2x is 5. From this second side, I can factor out a negative 1, leaving me with positive x plus 5. I can see that my two parentheticals match, which means I'm on the right track. I factor out the x plus 5, and I'm left with everything that's left, 2x minus 1, and don't forget that 2 is still there. No problem. That was example 2. All right, I got 2 more examples here. So, example 3 is going to be negative 7x squared minus 24x minus 9. Okay, so step 1. Is there anything that I can factor out of all of that? Technically, I suppose I could take a negative 1 out, and I think I'm going to go ahead and do that. I prefer dealing with positive numbers rather than negative numbers wherever possible. So I'm going to call this negative 1 times 7x squared plus 24x, because again, negative 24x divided by negative 1 is positive 24x. Negative 9 divided by negative 1 is positive 9. Lovely. Okay, so now we're going to deal with the trinomial in the parentheses. A times C is 7 times 9, which is 63. I need 2 numbers now that multiply to make positive 63 and add up to make positive 24. Well, I'm not so sure about that one. I know that 63 is 1 times 63. I know it's 3 times 21. There I am, 3 times 21, and both are positive. Now again, since I have 7x squared and not just x squared, I can't skip straight to the end. I have to split up my middle term. This negative 1, I am going to carry it down. I'll deal with it later. For now, 7x squared plus 3x plus 21x plus 9. So again, I haven't actually changed anything. I still have 24x here, and I still have 24x here. It just looks different. So now I'm going to do what I did before. I'm going to cut this in half, and I'm going to factor out x from the first pair. 7x squared divided by x is 7x. 3x divided by x is 3. On the other side, looks like all I can take out is a 3. 21x divided by 3 is 7x. 9 divided by 3 is 3. Once again, we have matching parentheticals, so I factor it out. 7x plus 3 times what's left, x plus 3. Whoops, let's not forget that negative 1. This is a very important mistake that I very nearly made there. Don't forget, when you factor something out at the beginning, you might be ignoring it for a little while, but it doesn't go away. So that negative 1 still needs to be here. So don't forget that. And that's example 3. Let's move on. 5x squared minus 30x plus 45. Okay, step 1, it looks like there's a 5 that I can factor out of all 3 of these terms. So I get 5 times, okay, well 5x squared divided by 5 is just x squared. Negative 30x divided by 5 is negative 6x. 45 divided by 5 is positive 9. Now some of you might at this point already recognize this trinomial. We've been doing enough of this that you can probably recognize this right away. But for those of us who don't have that already, what we need are 2 numbers that multiply to make positive 9 and add to make negative 6. Well, again, we've already worked with 9, so it's only 1 and 9 or 3 and 3. And it looks like negative 3 and negative 3 will get us to negative 6. Now again, because we have just this x squared here, we don't have to go through all the hassle of splitting the middle term. We could, it would still get us the right answer, but because we just have that x squared, we can fall right back on 5 times x minus 3 times x minus 3, better known as 5 times x minus 3 squared. Don't forget the shortcuts you've already got. You also know the patterns of perfect square trinomials and the difference of two squares. Don't forget those patterns. They will be very helpful to you.